Hello everyone, and now we are going to take a look at Ospf neighborship and Dr and BDR selection. Okay, so let us go. Let us start. So now we have no any Ospf neighborship at all. So let me use debug so I can make sure that Ospf, the process that it takes, because we want to take a look that the Ospf takes a certain stages to become a neighbors. And let me I'll turn the debug on, because this debug IB Ospf adjacency will tell us and the process is going through. So let me go to R2 as well. So say debug IP Ospf adjacency. ADJ is adjacency. Okay, let me go to R1 and say router Ospf 1. Then we'll just assign a router ID. We'll assign a router ID, and that router ID will be in anything. And that router ID will be, if we give a question mark, it will be any form, 4 digits or 4 digits, any 4 digits. So I'm going to give it 101.0 because it's not a routable anyway. It is just something that, giving a unique ID with this router. Yeah. So now, we're going to hard code it. This is a hard code. If we don't hard code it, then it will take the loopback IP address that we configured previously. So as we said, Ospf always needs a router, an active interface, and IP address assigned to that. If that happens, if there are two interfaces configured, one is loopback and one is a physical interface, it will take the physical interface we set before. Remember? We said it will take the physical interface if there is nothing else configured. So if there are two interfaces, loopback interface and physical interface, it will prefer the loopback interface because of its stability. Because if it is of its stability, because loopback unless someone deletes or shuts down, it will not just shut down by itself. But physical interface, anything can happen. But now we're doing even better, because we are just hard coding a unique IP address, because it doesn't matter whatever you write in here, it's just not routable. If it is a loopback, if we assign the IP address of our loopback in here, it is a routable because it's a normal IP address. But here you can say I said 0.0.0.0.1. It just I made the IP address of this router, so it doesn't matter. And whatever, I put it. It doesn't matter, so it's not routable, this one. So I will say network. So to know which route I'm advertising, I will just that's what I always use. Do show IP route, and then I will know the route is that I'm just so this one, the routes I'm gonna advertise it. So I will advertise this network and this network. So network 192.168.12.1.255.255.255.0 and area, because we will come to area, but now let's take an area 0, and then advertise 1.1.1.1, and then turn on all the 32-bit and make it an area 0 as well. So let me go to R2, and they say do show IB route, and then let us use include. That is the best option that you could do. And include show IB route, and include connected. So it will give you whatever connect is in here. So this is the IP address. We have not implemented that, guys, so we're going to configure that guy now, the loopback IP address. So interface loopback 0 IP address 2.2.2.2 255.255.255. So let me go to router Ospf. Even if you say like that OS and instead of Ospf, it will work. So I will hard code the router ID. I will give 0.0.0.2 on this guy, and then I will advertise my network that I had in here. So I had it 12.0. I just copy it and then give it 255.255. I turn on, I say like match on the first octet, match on the second octet exactly, and match on the third octet exactly, and then I don't care the host that is just off right now, and then I will give the area 0, and because the area must match, and then let me advertise on the other one, the one we just configured, area 0. Okay, now the adjacency must come up. So show IP Ospf and neighbors. So neighbors are not there. So let me, why the neighbors is not forming? So there is a troubleshooting problem here. So let me just show run. So what are we going to do, like the Ospf, that how we configure our Ospf? Let me check. Yeah, in here I said network 192.168.12.0 we are okay, and then I advertise it in this network. Let me go in here, show. Yeah, you see the election started because of the JNS3. It just took time. Okay, the reason I executed this command because I want to show you the process that Ospf takes to form an adjacency. So now it says like end of wait time. There is a wait timer which is a 40-second by default, yeah, on an interface, and then there was a two ways. So did it show us in here 2 ways? Show IP Ospf neighbors. It's not. And okay, let me show run interface gigabyte, if the interface is shut down or not. Yeah, this interface is shut down. You see, this interface is shut down. So now this guy, he cannot do anything. But let me just say show IP Ospf, and the Ospf, they changed the router ID. It took, because it has been hard coded, so it took 0.0.0.2. So now we cannot form anything, but it says, let me just configure interface. Let me just say like no shutdown. So now the process will start in here. Let me wait. Yeah, you see the process started. It should start down because here we said no shutdown. Let me go to R2 and show you the process before. There was a wait time here on R2. On R2, well, yeah, you see here there was a wait time, so it said a end of wait time because R2, it was waiting of R1 to come back, but R1 the interface was shut down, so it didn't it couldn't form an adjacency with him. But now, since it can, it started the process. So the process, you see, as you can see, is a two-way. So that's the second stage. The wait was this. The wait was the first stage because it was wait. The wait means this guy was waiting until this guy comes back to him, because it until that we configure the Ospf on this guy, but we configured it on router 1, but this interface was shut down. So it couldn't form it. So the wait timer kicked us in by the time we configured the router and the Ospf on this guy. But this guy did not respond. The wait is 40 seconds by default, and that's why it tells us the wait, the end of the wait, because this guy did not respond. But now when we executed no shutdown, everything became normal, and now it started to elect Dr and Bdr, and it started elected Dr and Bdr, and this guy became a Bdr because the election started and R1 won. So R1 is R2 has been elected as a Dr, this guy, and it's supposed to be because it has an IP, it has a loopback IP address, and R1 become what is R1? And R1 become a Dr. But this time, sorry, this I'm looking for before R1 came up. So anyway, R1 will be the Bdr because this guy has a higher loopback IP address, so it must be a Dr. But now, I mean, normal must be Dr, but some other circumstances exist. If we configure this one on the first place, and we come to second, we come to R2 and configure Ospf. If we configure this guy on Ospf, and we come while this one is running on Ospf, if we come to R2 and run on Ospf, this guy will take the precedence, and this network 1.1, this loopback will become a Dr, and we will not be, it cannot be changed unless we reload and we restarted the process. And that is other circumstances, that is the only other circumstances, but normally R2 will become a Dr. But now let us see, because they come up, so now in this circumstance R1 will become a Dr. So now two-way handshake, two-way started, because this is the second stage, and it is a two-way communication with R1, because you could see the router ID 01.0.01, and then Dr and Bdr election started, and R1 has been elected as Bdr, as you can see. Bdr has been elected as R1, and Dr has been elected as R2. And then Agassi start is started, because this we are on the Agassi start all the way to here, because Agassi start has so many things, you know. Dr and Bdr, that stage is the third stage. Agassi start is the third stage. So can we see an Agassi start right here? If you don't see it, then I'm going to go to R1, so you can see Agassi start here. So the Agassi start is where they change all the negotiation Dr and Bdr, and at the same time it has been, I mean, MTU is where the MTU is exchanged. Yeah, you see Agassi start. So all this way here, all that way here is an Agassi start. After two-way is an Agassi start, because Agassi start is where the Dr and Bdr is exchanged, and at the same time where the MTU is exchanged. So MTU, if the two routers does not match, MTU is called maximum transmission unit. That means like how many data they can send at the time that has been configured. So if this maximum transmission unit by default is 1500 bytes, 1500 bytes at a time. So if the R1 does not agree on this, the neighbor relationship will come up. If the Dr and Bdr, they need to have a Dr and Bdr, and the state is Agassi start. So let me come back to the Dr and Bdr, the meaning Dr and Bdr. Now we only have, by the way, Dr and Bdr concept exists only on Ethernet networks. Ethernet network is called broadcasting network. So it only broadcasting network. So it is only exists on a broadcasting network. It does not exist because Ospf has many types, but the main type is now is a point-to-point, which I will show you later on, and broadcast. So how do I know if it is if I am running on a broadcast? If I go show interface, show interface, show IP Ospf interface, then I will see, you see, I will see here network type. This guy is a loopback, but the interface a gigabyte. This is a gigabyte interface. RAM protocol is up. We are a member of area 0. We have a lot of information. Internet address is 12.1, and we are attached via a network statement. That's leave that, and we are attached with router 1. Okay, I mean we are router 1, and the network type is broadcast, and the cost we will talk about later on. So now the network is a broadcast. So Ethernet is always a broadcast. It's called multi-access. So Ospf is always I mean DR and BDR always exist in a broadcasting network. So that's why you know, if you have a multiple routers in here, they will only form an adjacency with the DR and the BDR. Otherwise there will be many updates, you know. So they don't want that update. So to minimize that many updates between the routers, so the routers will have the concept. I mean the importance of the DR and BDR is, if we have 50 routers, every router will advertise to the next router all of the networks that are connected, which is called type 1, and also the other router. I mean the other routers will advertise to each other. So there will be a injection in the network, and at the same time Ospf is a high intensive CPU. So to minimize the flooding everywhere, you know, that exists in the area, so that exists in the routers, because in the area that will be an area, the concept will be an area. But to minimize the flood that every router will send it to the other routers. For example, if you have 50 routers, every router will advertise this network to the other one. So this guy, if he had 10 routes, he will advertise this way, he will advertise that way. If he was connected another one, he will advertise that way. If it connected to another one, it will advertise that way. So there will be too many advertisement or too many updates. So DR and BDR concept is, they will have one DR, which is the head of the routers. I mean all the routers will agree that all the routers will form an adjacency only to that router. So that router will give, they will send all the updates to that router, and that router will send all the updates to the other routers, neighboring routers. So instead of every router would send every router the traffic, they will all send it to traffic to the router, to the DR, and DR will send instead. So they will minimize like tons of times, you know, the update that they would send it to each other, because it would be like so many updates, or so many, if link goes down, if link comes back up, there will be so many traffic going on in the routers. But now when they form an adjacency to all other neighbors, when they all the other routers, the one who is qualified to become a DR, and be the second highest one, because always the requirement is the priority. So if the priority is the highest, it will become the DR. But if there is priority is the type, but now the priority here is 1, and the priority in this guy is 1. How do I confirm if the priority is 1? So show IB Ospf. Let me execute this command to see the priority of the router. It was somewhere here. And yeah, let me just maximize the priority. Show IB Ospf interface. Was it that one? Just looking for a priority. The cost is 1. Cost is 1, but cost. Yeah, the weight I was talking about is here. That weight is always there. We are looking. I mean the start one. The priority. The delay is 1 second. Yeah, you see priority. Priority on the router is 1. So priority is based on each interface. So now the interface gigabyte interface, the priority is 1. So now since the priority this guy is 1 and this guy is 1, as I show with you, this one will be 1 as well. If I go down here, the network type, yeah, priority is 1 as well on the interface, gigabyte interface. So since the priority is a tie, then the highest loopback interface will be, the highest router ID will become a DR. So now this guy has a 0.0.0.2 will become the DR. So if you have a 50 routers and this guy for example becomes the DR, then they will all form the adjacency with this guy, and then with this router I mean, and then all other routers between the other routers they will stay in a state called two-way, and that's perfectly legitimate. And all other routers will become a DR address. So they will have a per segment. Yeah, I'm talking about per segment. So per segment, that means like every segment has a DR and BDR, and all other routers to that segment will have a DR other neighbors. So they will stay in two-way. So that is the concept between DR and BDR and the adjacency. So if I say like show IP Ospf neighbors, now we have a neighbor, and R1 is the BDR as you can see, and R2, and if I go to R1 and say show IP Ospf neighbors, R1 is the DR. Sorry, R2 is the DR. R2 is the DR for the segment of gigabyte 0/0, which is the one we only have right now. And I hope it has been informative. And see you on the next lecture.